There's something strange about dams. A massive wall stands in a river valley. Behind that wall sits an entire lake of water. Not a little bit of water, millions of tons of it. And most of the time, nobody is worried. People picnic nearby. People fish. Cars drive across the top. Life goes on, but water is heavy. Water moves and water pushes. So the question very few people ask is, why doesn't the dam fall over? Why doesn't all that water simply push the wall out of the way? That question sounds complicated. It sounds like something that only engineers should worry about. But the answer is actually very simple. Dams don't survive because they are strong enough in some mysterious way. They survive because they are shaped and placed in a way that works with how water behaves. This video is about understanding that in a way that makes sense to anyone. To understand why dams work, the first thing to understand is how water pushes. This bottle is filled with water. There's a small opening near the top. There's another opening near the bottom. Watch what happens. Water near the top comes out gently. It barely travels any distance. Now look at the opening near the bottom. The water shoots out much harder, straight to the side. Same bottle, same water. The only difference is how deep the water is. The deeper the water, the stronger the sideways push. That's exactly what happens at a dam wall. Near the surface, the water pushes lightly. Near the bottom, it pushes much harder. So water doesn't press evenly against the dam. Most of the force is concentrated right at the base. That single idea explains a lot. It explains why dams are thick at the bottom and thinner at the top. It explains why the lower part matters the most, and it explains why dams are shaped the way they are. Water doesn't need to move fast to be powerful. Depth alone is enough. Once that idea is clear, that deeper water pushes harder, the shape of a dam starts to make sense. A dam is not the same thickness from top to bottom. Near the top, it can be relatively thin. Near the bottom, it becomes much thicker and heavier. That's not wasteful. That's deliberate. The water near the surface doesn't push very hard, so the wall doesn't need much help there. But near the bottom, the push is much stronger. That's where the dam needs the most resistance. Instead of trying to be equally strong everywhere, the dam puts material where it's actually needed. More mass at the bottom, more weight pushing down into the ground. So the dam doesn't rely on strength alone, it relies on its own weight to stay in place. Some dams mainly resist water by being heavy. Others use their shape to pass that force into the valley walls. But in every case, the water still pushes hardest near the bottom. Once that is understood, the shape of a dam stops looking strange. It starts looking sensible. A dam is not just a wall holding back water. It also relies on the ground beneath it. All that water pushing sideways on the dam has to go somewhere, and eventually it goes down into the earth. The ground under a dam is doing just as much work as the wall itself. If that ground is strong and stable, the dam behaves calmly. If the ground moves, settles, or softens, the dam responds. That's why dams are not built just anywhere. They are placed where the ground can carry the weight and resist movement. Solid rock, narrow valleys, natural foundations that don't change easily. This is also why water is never allowed to freely move underneath a dam. If water were to seep through under the structure, it could slowly weaken the ground. Not suddenly, not dramatically, quietly. So dams are designed to control that as well, guiding water safely, sealing the base, and protecting the ground below. When people think about dam safety, they usually look at just the wall, but the real story continues underground. That's where the dam truly stands or falls. A common misunderstanding is that dams are built to trap water completely. They are not. If a dam tried to hold all the water back, it would eventually fail. So dams are designed to let water out on purpose and under control. When rivers flow into a dam, the water level rises. As it rises, the pressure on the dam increases. To manage this, dams have planned paths for water to leave. Some outlets release water slowly for everyday use. Others only come into play when water levels get high. These paths are not weaknesses, they are safety features. By allowing water to escape in controlled ways, the dam prevents pressure from building up where it shouldn't. This is especially important during heavy rains. Instead of water piling up behind the wall and pushing harder and harder, excess water is guided away safely. In South Africa, where long dry periods are often followed by intense storms, this control matters a lot. Dams don't fail because they release water. They fail when water is forced to find its own way out. And when water chooses the path, it really chooses a safe one. When people hear the words dam failure, it sounds sudden and catastrophic, but that's not how dams usually behave. Dams don't just collapse without warning. They are constantly watched, measured, inspected, and when dam problems do happen, they usually develop slowly. Small leaks, changes in water levels, movement that wasn't there before. These are signs engineers look for long before anything becomes dangerous. Most dam failures are not caused by water being too strong. They happen when the systems meant to control water are damaged, neglected, or are being ignored. Blocked outlets, uncontrolled seepage, erosion that's allowed to continue for too long. In other words, failure is usually the result of time and neglect, not a single storm. This is why maintenance matters as much as design. A well-designed dam that is cared for can safely hold water for decades, even generations. So while dams deserve respect, they don't deserve fear. Understanding how they work makes it easier to trust them and to know why looking after them matters. Dams are not just concrete walls in remote valleys. They are part of daily life in South Africa. They store water during rainy months. They release it slowly during dry periods. They help cities, farms, and towns survive long gaps without rain. In a country where rainfall is uneven, this matters a lot. One heavy storm can bring more water than weeks of light rain. Without dams, most of that water would rush past and disappear downstream. So dams are not just about stopping water. They're about timing, holding water when there is too much, releasing it when there is too little. And because dams work quietly in the background, it's easy to forget how carefully they are designed and managed. Understanding how dams work doesn't turn people into engineers. It simply makes the system less mysterious. And when something is understood, it's easier to respect it, maintain it, and protect it. Dams don't just store water, they store time. Hi everyone, the South African engineer here. If this explanation was useful, please like the video, subscribe, and turn on your notifications. Every subscription is a brick used to build the Engineering Explained house. Let's build this house together. Thank you for watching.